second type of form for an equation of a straight line is the slope point form of a line. Now for this one, you're going to need the slope of the line, and you're also going to need a point that lies on the line, or a point that the line passes through. So you're going to need those two things in order to complete this formula for the line. That is why it is called slope point form. And then of course it has a place for an x and y value, which is a coordinate of any other point on the line, just like the last formula we learned has. So in example 1, it says describe the graph of a linear function with this equation. Y minus 2 is equal to 1 over 3, x plus 4. So you'll notice that this is really similar to this slope point form equation we have up here, but it's slightly different. And the one place that it's different is that it has a plus sign there when it should have a minus sign there. So what I'm going to do is I'm going to rewrite this equation so that it has a minus sign here. And how we would do that is, so I'm just going to put a little arrow. So I'm going to keep the y minus 2 the same, equals 1 over 3, and I'm going to open my bracket and put an x. Now, I don't want it to say plus there, but what's another way that we can write a plus sign that is equivalent to it? Well, that would be like minus a negative 4. Because if we have two minus signs next to each other, that equals a plus sign. So now our equation is exactly in the form of the equation that's at the top of the page. So y minus y1 is equal to m times x minus x1. So now let's describe what's going on this line or on this graph. So let's start off with the m value. We know that m is always equal to slope. And in this case, the m value is 1 over 3. So we know the slope of the graph is 1 over 3. And now we also have the coordinate points of another point on the line that it passes through. So let's describe it with that. So we're going to say that it passes through the point x1, y1, or in other words, the x1 value that we have is negative 4, and the y1 value we have is 2. Now just be careful with those plus and minus signs there, because remember in our original equation, this minus sign is separate from this y1 value. So we have the minus sign here, and then we have the y1 value there. Same with over here, we have the minus sign, just like we have up here, and then we have the x1 value right next to it. So in the next part, they want us to graph this equation. So let's start off. Our first step is going to be to plot the x1, y1 point. Or in other words, in our case, it is negative 4, 2. So I'm going to start by plotting negative 4, 2 on our graph, which would be right over here. So I'm just going to label that as negative 4, 2. And then our second step is to do the slope, which is 1 over 3, from the point we just put on, which was negative 4, 2. So I'm going to do the slope 1 over 3. So remember, that is rise over run. So I'm going to rise 1. So that would bring us here. And then we're going to run 3. 1, 2, 3, because both of those are in the positive direction. And then I'm going to keep doing that rise and run to extend our line further. So rise 1, run 3, 1, 2, 3, rise 1, run 3, and so on. So now we can connect all of these dots and we have our line graphed. The next example wants us to write an equation in slope point form for this line. So you'll notice they gave us 2 points on the graph. I think there's also a point here and here. They just didn't put a dot on them for us. So I'm just going to say, I don't know, it's point A, point B, and we can write the coordinate points of both of them. So A we have at minus 1, minus 2, and B we have at 1, and B we have at 3, 1. So they want us to write an equation in slope point form. So remember, for the slope point form of a line, for the equation we're going to need a point that the line passes through, as well as the slope. So let's start off by picking a point that the line passes through. So we're going to say that it passes through point. Now, they gave us 2 options to work with on there. I'm just going to pick one of them. So I'm going to pick A, which is negative 1, -2. So that there is going to be our x1, y1 values. But I just want to make a side note here that you could have chosen 3, 1 as your x1 and y1 value. You will get the same answer no matter which point you pick. But now let's figure out the slope of this line. So we're going to do the slope from point A to B. So that's going to be the rise over run. And then let's just figure out what that is from A to B. So we're going to rise 1, 2, 3, and then we're going to run 1, 2, 3, 4. And both of those were in the positive directions. So rise 3, run 4. So that there is the slope, which is the m value. Therefore, we're going to have our equation y minus y1 is equal to m times x minus x1. And let's just plug in those values that we got. So the y and the x stay the same, the regular y and the x. So we're going to have y minus y1 we said is -2. That's what we have up here. And then that's equal to m, which is 3 over 4. Open the bracket, x stays the same, minus, and then x1 we have as -1. So we have some double negatives going on there, so let's just clean that up. So then this would equal y plus 2, which is equal to 3 over 4 x plus 1. So that there is our final equation in the slope point form. Now in part B, they want us to write the equation in part A in slope-intercept form. So we're going to have to convert from slope point form into slope-intercept form. So I will give you the steps on how to do this. So first I'm just going to write our equation in slope point form. So the first step we want to do is get rid of those brackets. So we are going to distribute this into the brackets. So step number 1, we're going to get rid of the brackets by distributing. So this y plus 2 is going to stay the same, and then we're going to distribute the 3 over 4 into the brackets. So we have 3 over 4 times x, that is just 3 over 4x, and then 3 over 4 times 1 is just plus 3 over 4. So now what we want to do is we are going to solve for y. And the reason for that is because the slope-intercept form is y is equal to mx plus b. So we got rid of the brackets because there's no brackets in that formula. And we also need to solve for y. We need to get y all by itself. So in order to do that, we are going to subtract 2 from both sides of the equal sign because that's going to cancel it out there. So then we're going to be left with y is equal to 3 over 4x plus 3 over 4 minus 2. And now our last step is just to simplify and we are done. So we need to combine these two numbers together. So in order to do that, we need to get that common denominator. So we're going to have y is equal to 3 over 4x, and then we have plus 3 over 4 minus 2 over 1, and we can actually get that common denominator by multiplying this by 4 on the top and the bottom. Multiply that 2 over 1. So then we have y is equal to 3 over 4x plus 3 over 4 minus 8 over 4. And now we are able to simplify these two together. So we have y is equal to 3 over 4x, and then we're going to have plus 3 minus 8 because that's in the numerator, and whenever we add or subtract fractions, we always add or subtract the numerator and the denominator stays the same. So plus 3 minus 8 leaves us with minus 5, and that denominator stays the same. So our final answer is y is equal to 3 over 4x minus 5 over 4, and that there is in the y is equal to mx plus b form. So we got the b is here, minus 5 over 4, and the m is 3 over 4. In example 3, we need to write an equation for the line that passes through r, which is 1, -1, and is parallel to this line here. So this line is in slope-intercept form. So remember that's y is equal to mx plus b. So we know that this here is the slope. M is the slope, which is 2 over 3. And then this little part is the y-intercept. The y-intercept, which is -5. So if we need to write a line that is or the equation of a line that is parallel to this, any line that's parallel to y is equal to 2 over 3x minus 5 needs to have the same slope as it. So I'm going to put here that exact thing. So I just wrote here that any line parallel to y is equal to 2 over 3x minus 5 also has the slope 2 over 3. And we know that it must pass through r, which is 1, negative 1. So if we have the slope and we have a point that it passes through, that means we are going to use slope point form because we have all of that information. So remember, our equation for slope point form is y minus y1 is equal to m times x minus x1. So now let's fill in the information that we have. Remember, the point that it passes through, which is over this r point, is going to be x1, y1. So when we put it into the formula, we have y minus y1, which is negative 1. And that's equal to the slope, which is m, so 2 over 3, x minus an x1 is 1. And then we can simplify this equation just a little bit by getting rid of that double negative sign. So it would be y plus 1 is equal to 2 over 3 x minus 1. So that there is an equation of a line that is parallel to our original line and passes through 1 minus 1. So let's do the same thing, except this time it needs to be perpendicular to this line and passes through that line. So again, remember that this is the slope, which is equal to m. And if it's perpendicular, then the slope would be the negative reciprocal of 2 over 3. So therefore, it would be negative 3 over 2, because that's the negative reciprocal. So now we're going to use the same slope point form formula, since it still needs to go through that point r. So we have y minus y1 was negative 1 is equal to, but this time the m is negative 3 over 2, and then we have x minus 1. And then we can clean that up by getting rid of that double negative sign. So basically the same as part A, except a different slope.